Let's start chapter 3 by looking at exponential graphs, and then later we'll look at linear decay models. So an exponential graph is when we have our x power in the exponent. That's what makes it exponential. And exponentials are great because they can grow very, very quickly. If we were to graph the function y equals 2 to the x, you would see that the first obvious point is if we plug in a 0 for x, we get 2 to the 0, which equals 1. And so a lot of exponential graphs, if you don't do anything to them, will go through the point 0, 1. And you'll notice that every time x increases by 1, it's 2 times 2 times 2. So the first point would be at 1, 2, then 2, 4, then 8, and so on and so on. So 2, 4, 8, 16. It gets big really fast. If we go this way, you see that it gets halved every time. So -1 would make it a half, -2 would make it a fourth, -3 would make it an eighth, and so on. So the graph looks something like this as an exponential. Now, one thing that's interesting is if we have y equals a to the x, and we want to take the derivative of that, it turns out that the derivative is dy dx is equal to a to the x times the natural log of a. And I won't do the proof of that right now, but that's what it ends up being. Y equals a to the x, the derivative of that is the graph over again, ln of a. So that's definitely a formula you'll want to hold on to. And watch what happens if we plug in e to the x. Imagine y equals e to the x. Well, that means dy dx equals e to the x ln e, just like by following our formula. And you'll notice that the natural log of e is just equal to 1, and so we get that dy dx is equal to just e to the x. So that's kind of an interesting one. If y equals e to the x, the derivative is its own function, which I think is incredible. So that's definitely something to know. The derivative of e to the x is e to the x. So let's use that to solve a couple examples. Our first one is if f of x is 10 plus 3e to the 4x, find the derivative. Well, the derivative of our constant term would just go away, which leaves us with the derivative of 3e to the 4x. Now we know that we can pull the constant off, and we know that the derivative of e is e, or e to the x is e to the x, but then we've got to notice this 4x. So we would start by, what we've got here is the chain rule. So we start by taking the derivative of the outside, which would just be 3e to the 4x, like that. Now, that would be the answer if this was just an x right here, but because it's a 4x, we need to go ahead and apply the chain rule, and so we just need to multiply our answer by the derivative of the power. So the derivative of 4x is 4, so we have to multiply the whole thing times the derivative of 4x, which is 4. So the final answer then is 12, because you can do 3 times 4, e to the 4x. That would be the slope of this equation, of this function up here. So just to recap, we took the derivative of 3e to the 4x. That's 3e to the 4x, but then we got to do the chain rule of the 4x. So we multiply by the derivative, which is 4, giving us 12e to the 4x. Let's do another example. It says differentiate x to the 8e to the 7x. In order to do this, we'll do the product rule. So call this first one f and call the second one g. So the derivative, if you remember the product rule, is f prime g plus fg prime. So that's what we will do. Sorry, I lost my focus there for a second. That's what we will do, and we will take the derivative of this function. So we'll start by taking the derivative of x to the 8, which would be 8x to the 7. That's f prime. Now we just multiply by g, leaving g alone, so that's e to the 7x. And that would be the first half of the product rule. Now we'll do the second half of the product rule. This time we leave f alone, so that would be x to the 8. And now we take the derivative of e to the 7x. Now the derivative of e to the 7x is just e to the 7x. It's the easiest derivative you will take. However, again, notice that the derivative of e to the x is e to the x, but because our power is a function, we need to multiply by the chain rule. So the chain rule of 7x, the derivative of 7x is 7, and so that gives you the final answer right there. So we can write that x to the 7 e to the 7x plus 7x to the 8 e to the 7x. And that's the answer. You could factor out a bunch of stuff, I suppose, if you wanted to. So if you wanted to, you could factor out x to the 7. Oops, I'm sorry. There should be an 8 there. So if we wanted to, we could factor out x to the 7 e to the x if we wanted. This is optional. If we did that, we would get e to the 7x, I mean. If we did that, we would get here 1 plus, or 8 rather, plus 7x. So that's what you can get if you factor it out. But honestly, any of these three answers would be okay in my book. So anyway, hopefully that wasn't too confusing. In the next video, we will look at some more examples.